Hi everyone, welcome and thank you for joining us at today's event on the triple impact strategy for high ROI AI for our business and technical leaders. I'm Chairman from SGInnovate, and if you're new to us, SGInnovate is a Singapore government-owned organization with the mission to build, grow and scale our deep tech innovations in Singapore to improve lives for many around the world. So besides working with entrepreneurial scientists and clinicians to bring their innovative research from lab to market through equity-based investments, we also develop technical talents for suitable roles in the deep tech ecosystem and engage with the vibrant marketplace and community. So some of the fields that we invest in and grow startups include medtech, quantum, and artificial intelligence, to name a few. So we have invested in over 80 portfolio companies to date, including AI.Reverie. So we have been supporting AI.Reverie in the works of providing computer vision algorithms and synthetically generated data at scale, with current applications in the retail, agriculture, consumer packaged goods, and government sectors. Today, we're very happy to partner with AI.Reverie to bring together our expert panel. So we have Dale Kim, founder of AI.Reverie. We have Simon Crosby, CTO of Swim. We have Josh Elliott, Head of Operations at Modsy, and our moderator for today, Annabelle Cheong, Deputy Director of Venture Investing from SGInnovate, to share and discuss about the three concepts to attain high return of investments through the use of AI. So without further ado, let me invite Annabelle to start the session. Annabelle, please.
Thank you, Sherman. Good morning, afternoon, or evening, whether you are in Singapore or watching from overseas. A very warm welcome. We're glad to have all of you here with us for our online panel discussion. So first off, we'll begin with a quick round of introductions. Panelists, please share what you do briefly.
Should I start?
Over to you, Dale.
Great. Okay. So my name's Dale Kim. I'm the founder, CEO of AI.Reverie, which Annabelle said is a simulation platform to train the future computer vision algorithms. So excited to be here, and thanks for having me.
Thank you, Dale. Simon?
Hi there. I'm Simon Crosby. I'm the CTO at Swim.ai. And what we do is we do a thing which I'll call continuous intelligence, which is essentially building models on the fly from streaming data, training them from streaming data, and then analyzing, learning, and predicting on the fly without storage.
Thank you, Simon.
And good evening or good morning. My name is Josh Elliott. I am the head of operations for Modsy. We really make taking enterprise artificial intelligence capabilities and models that organizations have been building for decades now, and really taking that and making it easy to scale that to organizations. So we're excited to be here. Thank you, Dale. Thank you, AI.Reverie and SGInnovate for hosting us today.
Thank you, Josh. Thank you, panelists. And I'm Annabelle, and I have the exciting job of working with startup founders like Dale, and of course, also many other startup founders in Singapore and overseas. So as some ground rules, I'll ask a few opening questions and leave lots of time for all of you in the audience to participate. To ask the question, simply type it using the Q&A function on Zoom, and we'll get to them. So AI is often talked about, but what does it actually mean to deploy it in business and to get a high ROI? So together with our panelists, I'm excited to explore the many different ways to achieve that. To get us started, panelists, what gets you excited or what fascinates you about AI in business?
Yeah, so I can start first. I'll talk a little bit about what excites me. So, AI.Reverie is focused on solving computer vision problems. And for a while, the standard paradigm when it came to training computer vision algorithms has been this idea of collecting data in the real world through images and then using humans in the loop to label and things like that, and do that really expensive manual annotation process. And our belief at AI.Reverie is that there's actually something really missing. And actually one of the things that actually slows the acceleration of computer vision is the things that real data lacks, which we can solve through simulation. So examples of this is, how do you deal with edge cases? How do you deal with things of issues of privacy? How do you deal with all of these side problems that real data is really hard to scale? So our belief is that synthetic data is going to be a sort of fundamental part of actually accelerating computer vision. I'm happy to talk more about that. So in terms of what excites me is changing that paradigm, making people really understand that actually real data plus synthetic data is what's really going to help push computer vision to the next generation. So that's what excites me.
Thank you, Dylan. Looking forward to seeing this paradigm shift as well.
So I'll have a go. My world is interesting because 20 billion devices are being attached to the internet every year. And whereas, we had this cool idea to use AI and algorithms that could suck data off of hard disks, you really can't when you're faced with that many devices. And so you have to start to build models from the data on the fly, let them scale and deploy themselves and find stuff that's interesting. And the extent to which we can do that is unknown, but it's a very interesting area. By way of tempting you to ask me some crazy questions, we're currently doing this online analysis, learning and prediction on 4 petabytes per day, okay, in the US. That's a ton of data. And we don't store the raw data. So I'm fascinated by what we can do from learning from data without knowing much.
And I'll answer the question. What really excites me the most about AI is that it truly is a fluid and emerging field. Anyone can sit down, design, and implement an AI solution that's likely to be state of the art. And one of the things that also fascinates me is that we're seeing this over and over again. We've seen this pattern of organizations or even data scientists at the personal level building these models. And what we're learning is that only 50% of those models are actually making it into production. And what we've done is filled this void, this niche in terms of machine learning operations, and have given those individuals, those organizations that are building those bespoke models, an opportunity to really live in a production environment and at scale. So really giving people an opportunity and organizations an opportunity to responsibly deploy and manage and scale their AI across their enterprise.
Thank you, Josh, and thank you, panelists. Certainly a lot of interesting nuggets for us to think about, and certainly very exciting things, and hopefully all of these things that we'll see upcoming, being deployed, the models, and even what we can answer from the petabytes of data that we get every single day. So let's jump right in also into some of the concepts that this discussion mentioned about. So first of all, the concept of transfer learning. What are some of the benefits of transfer learning that you've experienced or that you know of? And how has transfer learning actually allowed your clients to scale and have some benefits?
Great. Yeah, so I'll take a stab at that. So transfer learning, for people who don't know what it is, it's sort of taking like a trained model that might have learned something from one data set and being able to use some of the knowledge that it acquired from that training to then be able to use for another problem. And so just by the definition of transfer learning, it allows you to train less and maybe use less data to be able to be more efficient with your models and to be able to then apply it to other things. So example is maybe you trained an algorithm on detecting cars or certain sedans, and now you can just use a little bit of data to learn it, to transfer that learning to then learn how to identify pickup trucks, right? So that's just a concrete example. In terms of computer vision, in terms of how we think about it, actually, there's a sort of interesting way we actually apply transfer learning to our enterprise, which is the idea of using a combination of synthetic data that comes from a simulation, and using real world data. So imagine sort of training a neural network or a deep learning algorithm with sort of data that comes from a simulation, and then just using a little bit of that real data to then transfer that knowledge representation to a certain camera sensor that can then be used without having to collect all this real world data and label that. So that's an example that we find to be really exciting. And I'm sure there's other examples that the other panelists can talk about as well. So,
how do you control for accuracy?
Great question. So the controlling for the
Sorry.
accuracy, at the end of the day, you need real world data to benchmark against, right? So if you were to have your training, validation, test, all that, what you do is you might use a little bit of the original training data to fine tune your model once you train it on synthetic data. So it's a way of sort of, understanding how well. So the more you use of the real data, the less effective the synthetic data is. So there's always a ratio. And in academia, you're finding that some problems, you might not need a lot of, real data, or you might need, very little of it in order to get really high performance. It actually brings up all sorts of interesting relationships there in terms of the kinds of domains in which synthetic data does really well versus other domains where it's much harder. So
right, and then you have to track an algorithm in practice, right? Once you deploy it beyond the training data set.
Oh yeah, absolutely. Once you get that into the real world, you're then learning from it, and then you're sort of seeing how well it does. And often that's just qualitative, right? If you're actually deploying it to the real world on the edge there. But
right.
yeah, it's a hard problem. But yeah, so.
I think some of the things, Dale, that you shared, some of the examples are spot on, and Simon, your point about accuracy is also spot on. I think in terms of some of the retraining solutions that we provide at Modsy, in some cases we've learned that the retrained model actually works better on the new data set than on the model it was originally trained from scratch, because the retraining solutions that we have are capable of efficiently combining and utilizing both the initial knowledge gained during the training and the new information gained during the retraining of that on that new data set to perform the task. And we're seeing significant performance improvements. And just in 16 minutes worth of time on one GPU, we're seeing a rise in people detection type of models to 45% on precision compared to a 5% benchmark. So it's an amazing technology. It's amazing technique that's out there and that exists today that can really accelerate and provide a starting point for people that are training on different data sets or tasks.
It feels very human too, right? Transfer learning is one of these things. And if you're good at, a certain sport, you might actually be good at another sport. Michael Jordan decided to do baseball after basketball. Still
That's
great
right.
at that. Anyway, I'm getting off topic here, but yeah.
No. I think just again going back to the benefits of transfer learning, and I think Josh mentioned some of the cost savings. Is it also a way, Josh? Is it also a way to pass on cost benefits? Making AI cheaper to access for the enterprise.
I think so. I think if you think about the data sets that exist and the models that exist in the open source environment, many data scientists that I'm aware of or that I know start with an open source model and immediately think of transfer learning. It's kind of the method that they take. And when you have a retraining solution that's lightweight, where you don't require a large training data set or a significant computing resource, I mean, this leads to significant time and cost savings that an organization can experience.
Simon, do you use transfer learning at Swim?
No, but that's a great question. I'll tell you a cool example. If you go to traffic.swim.ai, you'll see Palo Alto in California, where every intersection is learning and predicting its own future 2 minutes into the future, okay? And this is a solution which is deployed in a bunch of US cities. And so these little objects, you could think of them as actors. Each one of them learns on its own sensor data and that of its surroundings continuously, right? So it's continuously projecting its own future. Now, these are very small models, typically 1,000 inputs or something like that. And they can run very efficiently on low power devices. And each one of them runs independently of all others. So the cool thing about that is that they can do an unsupervised learning step, which is take a guess, posit a future, see what happens, and then back propagate. And you can track their convergence over time. So you know whether you're doing well, and they just sit either open loop, or you can decide when you've hit, sufficiently accurate and turn off training.
That's pretty cool.
Thank you. So I'll move on to the next question. AI is often talked about by business leaders, but many are unaware of how difficult it is to scale AI in deployment. Can the panelists share briefly about some of the more pressing issues that business leaders should be aware of when they scale AI in deployment?
I'll take a guess. So first of all, I don't think AI is a panacea. It's just an application of a set of algorithms, a set of techniques that we've known about for a while. And we now have the ability to efficiently compute on. And so I think of it as yet another tool in the toolbox. Just like linear regression, which we've always known about forever. So it's a tool, and absent a vertical application, it's not an answer to anything. It's just a tool. So every customer I talk to has got a goal in mind. They want a better oil rig or better streets or something. And then the question is, how can AI help? Right, so AI, approaching the solution from an AI first mindset, it doesn't really work for me. It's more, what is your outcome and how can I get you there, and where does AI fit? And so I think the problem that we as technologists have is translating. We tend to come at the world from the technique and technology perspective, and we think, hey, I've got this great thing. It's the greatest thing since sliced bread. But the customers really think about the problem in terms of a realistic outcome. And we have this translation need, which is to take a customer from their business goal down into the use of AI. That isn't always easy.
Yeah, I think I would agree with that as well. Sorry, Josh, did you want to say something?
No, please. I'll talk after you.
Yeah, I think being able to really understand what the problem is so important. So being able to know what you're trying to solve is important, because if you're trying to solve, let's say, the self-driving car problem, like, good luck. That scale is there's a really long tail in terms of that problem. It's a really hard problem because you have to get to mission critical, right? So you can't just have a self-driving car that only works 95% of the time, or even 99% of the time. It needs to work 99.999% of the time, because the failure is death, right? So that's very important to understand. What does it mean to be successful when it comes to an AI application? And the other thing I would say about, in terms of scale and how you actually maybe think about scaling the performance of it, is also thinking very carefully about how you improve the algorithm. So do you have a process in place where you can actually take the data, learn from it, and actually keep improving an algorithm past that point, right? Or if it's a one-time solution, you might actually implement an AI product and it doesn't actually, it fails at the end of the day because you can't improve it fast enough, right, for it to be a successful product, right? So I think those are two things that come to mind for me, thinking about how difficult it is and what your expectations are, and then being able to have a process to constantly improve it once it's in place.
So is there a corollary there, which is effectively, if the marginal cost of being wrong is high, don't do it?
Sure. If it's the cost of someone's life,
Yeah.
you're gonna have to put a lot of investment in making sure
Right.
it works. Right?
Yeah, I think there's context there.
Yeah, but if you're, yeah, please, Josh.
No, I was just going to say, I think, if you think about a majority of the models that are developed today, they're built in a pristine lab or in a cloud environment that you've structured, and with consistent network connections and updated software versions. And I don't know a real world that has that nominal type of scenario. And we live in the world where there's rigid architectures and inconsistent networks, and talking about, the safety critical mission of saving someone's life or protecting someone's life, you think about, how artificial intelligence is supporting a military or defense type of mission space. I mean, that is very critical. And I think one of the things that when I think about deploying AI at scale, it's really an extension of a challenge that we've been trying to solve for years in the software industry. Bringing together the diverse skill sets of both your software developers and your data scientists, and trying to create something that's frictionless between them that gets to what Simon was talking about, AI as an outcome. And I think if we can start moving towards that perspective and that way and approach of building solutions that are enabled by AI, I think we get into a really good place. And I think the other key thing that perhaps some of the audience is going to be learning about are terms like machine learning operations and model operations, and what does that mean to provide the model governance, the management, and we've touched on monitoring. How do we know and how do we get the telemetry back that a model's drift occurred and it's time to retrain or take that model back into an environment to retrain it? I think these are all critical points that business leaders and technology leaders need to be thinking about. And it's something that having that insight into the real-time performance of a model and the audit functionality, I think those terms, the model ops and ML ops, are going to become even more critical here in the near future.
Hey, I'll give you a cool example of a big fail. And that was merely predictive maintenance. And what we were doing is predicting when chip shooters, which are putting chips onto boards for computer manufacture, were about to fail. And yeah, it's statistics, right? So every once in a while, you're wrong. And so the learning is that if you call the operator back from lunch and the machine does not need fixing, you are a fail, okay? And they have a vote. And they're very loud. But there's another piece of this, which is that the current mode of operation, which is lots of failures, is already baked into the cost. And so, it's easier for them to just say, yeah, you use this, and their budget already includes failure, right? So it's hard to demonstrate consistent improvement without business leaders taking a stake.
Thank you, panelists. So we have a question coming up from the Q&A chat function. It's from Barry Shelley, and I think just wanting the panelists to distinguish the you in the context, whether you're talking about the business person or the technology guy creating the algorithms, because mindful that there might be business people, but there are also technologists in the audience. So if you can make the distinction when you're talking about whether the benefits or the problems or the issues to take note of, and whether also
that's absolutely, I mean, that's spot on, right? That's the key.
Yeah, and I think the comment from Barry is also whether it's a translation issue or is making it real the issue. Any comments about that?
I think we have to make it real, which, by the way, there's a very good blog post from Martin Casado at Andreessen Horowitz, which basically says that in all their AI companies, the margins are lower. And that basically the translation of the customer's problem into analytical space and the understanding of how to use technology to solve their problems always increases the kind of the services cost of being in business, and that lowers margin.
Yeah, it's really hard to find an algorithm that can do everything, right? Oftentimes you really have to sort of do a little bit of tweaking and custom configuration. And, and I know Modsy, you guys are doing things like that. We're trying to be able to sell algorithms in the marketplace. And I think there's some really interesting challenges there too. But it is a challenge for sure.
And you have to train people too, because people are going to use them. So
exactly,
that's exactly right. We're trying to make it, democratize it a bit, and in terms of the utility of it. And I think you're seeing in the marketplace a convergence around standardization of container specifications and APIs that make access to models and algorithms a bit more like I said earlier, frictionless for the software engineers that are actually building those enterprise applications to serve that vertical outcome.
So Dil, you touched upon this earlier on the topic of synthetic data. And I think synthetic data, so can you share with the audience, or can the panelists share with the audience, why is synthetic data important? And I think just from two perspectives, what do business leaders need to know, and also what do the technologists need to know?
Yeah, so I'll say, synthetic data is broad. You can use it for things like language. You can use it for, I'm going to focus on vision because that's really our area of expertise. But the way that businesses should think about synthetic data, at least in computer vision, is that if you have to compete with another company that has synthetic data and real data, and all you have is real data, the ability to scale, their ability to scale is going to be much faster than yours, right? Because and sometimes I'll say this, but the only advantage of real world data is that it's real. But when it comes to anything else, synthetic data has an advantage, right? So you don't have to worry about the annotations. There's no humans in the loop. It's all ground truth, automatically generated. It scales with GPU cost. You can model scenarios that never existed before, so unforeseen things, as well as things that are seen. There's privacy issues. You can't collect data off of someone's interior home. There's real issues on just even capturing the data. And sometimes even your computer vision application might change, your perspective might change all of a sudden. And with deep learning algorithms, if your perspective changes, then all the original data you use has to go out the window, right? So it's things like this where you can just change the camera, change the lighting conditions, change the weather. So as a business person, if you're a business person interested in using computer vision for your business to solve a very important problem, you should seriously consider synthetic data as an option and as a complementary source to real data, right? And the other thing I will add to that is that synthetic data works really, really effectively for things like narrow AI problems, where you might think about consumer packaged goods. You might think about things where it's not, the diversity of the data is relatively narrow, meaning that, on the conveyor belt, mugs that are coming out there, synthetic data, in our experience, you can primarily use synthetic data and no real data and still get near perfect performance for simpler things. And as the world gets more complex, then you need a bit more real data. But it's just, as a business person, I would say, think about how important the computer vision solution needs to be, how the performance and being able to scale that, and synthetic data will really help there. So that's our perspective on it.
Hey, Dale, just to follow up on that, question for you.
Yeah,
sure. And we talked about accuracy and quality earlier. I'm curious in terms of your experience in synthetic data. Is that diversity, do you get the comprehensiveness that you need in terms of being able to understand all the different scenarios? Can you simulate that with synthetic data? And then how does bias come into the picture? And from a technologist perspective, like how do you prevent that or mitigate that?
It's the enemy of synthetic data. So the things you have to solve with synthetic data is diversity, and you hit the nail on the head. So it's the diversity, and the other side of the coin is that bias, right? So if you have no diversity, then it's just bias to sort of think in one way. So the way we look at it is so much of our IP is around how you scale diversity. So photorealism is not nearly as important as that diversity problem of how do you create all sorts of novel scenarios, all sorts of unique environments, all sorts of different objects and things like that, right? So that is the thing you have to get right. And if, there are KPIs that are tied to that, and if you can keep pushing on that KPI, your synthetic data gets better. And that's why the problem with conveyor mugs down the thing, there's not as much diversity there. So it's a little bit of an easier problem to solve with synthetic data versus self-driving cars, where you're dealing with the world, right? But unfortunately, you still need simulation there, because you can't, get data, let's say, on an elderly lady jumping in front of a car. Like, that's not real world data you can achieve. So things like that are important. But yeah, I think it's about maximizing that diversity, and ultimately you have to benchmark it. You train the algorithm, you have to see how it does on real data, and then we have a process where we're trying to learn from it all the time. So then we retrain it, see how well it does, retrain, improve the synthetic data, keep retraining.
So I have a use case which you might not think of as synthetic data, but it's what we do. So if I have a digital twin of an intersection, say, which is predicting its own future sometime out, we use this for causality. So in the middle of the night, there's not much traffic. It's easy to do. We just randomly perturbate the inputs, okay? And the inputs, this is all stream processing. So as every car crosses a loop or for every light change, we are literally seeing what would happen and changing the predictions, but we can also simulate them. And that helps us with causality. And so one of the areas which is kind of cool is you can say, well, if a pedestrian crossing 3 roads up, if somebody hits a button in rush hour, it's really bad. And we can find these things by, really stupidly, I hate to confess this, randomly kind of perturbing the inputs into our models, which are deployed and operational and processing data. But we can perturb the inputs and see what happens.
Yeah,
and that's
absolutely.
I think, Simon, you bring up a really great point that I was going to touch on, is that there's a nefarious side to synthetic data too, right? And how adversaries can perhaps poison the data that's being used to create inferences and outcomes. And I think those types of attacks, whether it's data poisoning or inversion attacks, is something that from a business and a technologist perspective, you need to be aware of it, and you need to have mitigations in place to be able to understand and make sure that your models are robust to defend against those types of attacks.
Yeah, you guys really care about bias. I think traffic lights don't really care about it quite so much.
Yeah, of course. Yeah, definitely at Modsy, like being able to ensure that there aren't ways of attacking an algorithm and fooling it is going to be super important. Yeah,
that's correct. Yeah. We're excited
Definitely.
about that feature.
Oh yeah, absolutely, for sure.
So we have a question from Kunal Ghosh, and his question is, how do you decide when to invest in AI algorithm development versus using off-the-shelf AI APIs by big players such as Google and others? Can we have some pros and cons?
I have strong opinions, but I'll
please.
let the others go. Look, AI is just a set of tools in the toolbox. It's an area that's being rapidly developed by academics and companies, but the general trend is towards publishing in open source. So I'm a strong fan of picking up what's available. And it's pretty clear to me that except in a particular niche where a thing isn't generalizable or it's of particular value, that algorithms make their way into open source code bases. We have, affine transformations available in code bases. We have regression and all sorts of statistical functions. Why not machine learning? So it's really just the timescale upon which these techniques trail the state of the art. And thus far, from what I've seen, it's pretty good. So I'm a strong fan of picking up what's out there, not reinventing the wheel. Do you use a big service from a cloud or not? That's really up to you, and whether or not you have the control of your data and the outcomes, and whether you've chosen that as the application platform.
To add to that, I think, listen, Modsy has a marketplace of pre-trained models that include open source, that include commercially available models, and we've talked about the importance of being able to retrain those models. I think to answer the question, it depends on your organization. It depends on what your resources are and what your time frame is. If you have a budding data science practice and you're evolving it, starting off with a machine learning algorithm that's either an open source or commercially available could get you 70% of the way, 80% of the way, and that's generally better than where you are today, perhaps. I think if you have the resources to develop your own model, I think it puts you into a better place. And Dale talked about the ability to combine data sets with your own and those publicly available and give you that data diversity. And you combine that with retraining, you've got a pretty powerful solution there for you. And with respect to the cloud service providers and the capabilities that are included in those marketplaces, I think they're great. I think they're certainly an avenue to get to those outcomes faster, but you have to evaluate, do you want to put all your eggs into that cloud service provider's basket, or do you want to have some open aspect to how you use and leverage that capability across your organization? And those are some of the business types of questions and perspectives you need to evaluate.
Yeah, the only thing I will add to that is there's often like a middle ground with tools like AutoML where people are sort of actually uploading some images of their own and trying to have like Google train the algorithm for them and things like that. So that might be certain things you might want to look at. But I think it's just a spectrum of control. You know, if you want to have absolute control over your AI application, you're going to want to start developing it on your own. And because without controlling both the process of data, its training process, and how you would deploy it, you're so subjected to the whims of the person who provides that service. So it's something to consider.
I think also, just to close this out, Annabelle, I think transparency into the actual model. What is the architecture? What is the data that it was used to train it and validate? And what is the pedigree and provenance of that data? And I think those are very important traits, in addition to the performance metrics associated with it, that data scientists and users of those models need to have access to and need to understand before they go in and start using models.
So I hope Kunal would have some nuggets of information to decide on which ones to use or how to go about making a decision. So we have another question from the audience from Chu Kok Liang. He says that there's been a lot of debate about how to train AI in ethical decisions. For example, the trolley problem. How far do you think AI can be trained in ethics, or is that unworkable? And I would like to also add another dimension to this. How far do you think concepts like transfer learning, synthetic data can even be used for this AI and ethics problems and decisions?
Yeah, that's a big one. I mean, ethics in terms of AI and how we think about it is going to be a very big question that a lot of people ask. I would say I would kind of go with Andrew Ng on this one about the trolley problem. I mean, I think it actually can be kind of distracting to think about that as an important ethical question. I think the bigger ethical questions around AI for me are what it's going to do to the labor force, what it's actually going to do to replace people's labor and remove jobs that actually can feed a family, right? So those things, I think there needs to be more attention to the way AI is going to disrupt the labor economy and how we mitigate for that. So that's one thing I would say. Another thing I would say, I have a lot of thoughts on this, but I'll just say one more thing. The synthetic data is interesting in the sense that it's very controllable in some ways. If you have a deterministic seed and you can sort of control your simulations, you do know what you're putting in there, versus sometimes with just raw data. And GPT-3 is an example where there's so much data in there that's been trained on, it's hard to know what it's been trained on, right? So or biases in the way certain algorithms have been on the press. So I think being able to control how the data goes in and being able to understand that data is important for ethical reasons. So you don't create algorithms that bias the predictions for certain types of things to happen, right? So that's another aspect of the ethical question that's worth thinking about.
So my expertise is mostly in the industrial application, but the techniques apply anyway. I think broadly the concerns that everybody shares are broad use, what are the effects going to be, and can we avoid bias? And maybe a simple way in is to say, no, we can't. And people are humans, and even trying as best they can to make something unbiased, that will still screw it up. So the best thing to do is to have mechanisms for people to question the outcomes, right? And if we can have ways to quickly fix algorithms or understand bias, that will be a great help. So instead of accusations of bias and evilness, what we need to do is establish practices whereby users of systems quickly give their inputs to improve predictions or remove bias.
Yeah, I tend to agree. Now, listen, as the COO of a software company, it's one of my jobs to make sure that we have the controls in place to proactively assess and mitigate the social and ethical implications of this emerging technology. And I know that, you know, the pursuit of moral knowledge and philosophical ethics is something that I'll leave to the academics and the policymakers. But tactically, I think, you know, as we inject ourselves into the various branches of moral theory, you know, my goal for my organization is to frame and provide a framework for us to effectively triage what those risks are and that we may face as we apply these AI techniques to the businesses that we support. So I think there's an opportunity out there for organizations to really peel back the layers of the onion and understand what their organizational values are, as well as their societal, and how it all lines up to the individuals that are building the models, and really treating ethics and explainability as another dimension of a systems engineering type of life cycle.
Yeah, I mean, I will say that, you know, a lot of people talk about AI and the neutrality of technology. I think that still applies to AI, but I think what it does is that the AI will be a mirror of a society's ethics. How we use it will actually represent the moral framework of a society, right? So that's something that actually is going to be, it's an empowering technology in every aspect. So how people use that empowerment, that's an interesting thing to observe and to focus and to be mindful of.
Thank you, panelists, and certainly food for thought for us, and especially like what Dale had mentioned of AI being a mirror of the ethics in our society, and to see how that develops or plays out. So we have a question from Michael Chong, and this is about, you know, the pandemic. You know, the pandemic has literally changed the world, but how has the pandemic changed AI, especially when we're talking about, you know, models and data, when all the models might not even make sense anymore, and all the data, the past data, is not relevant and irrelevant anymore. So what are your thoughts about that?
Well, at least I'll give an example of how it's affected us personally in the pandemic. What people are now more interested in actually is preventing their workers to be exposed in the workplace, right? So cashierless shopping is actually a thing that's become more, I think, active as a result of the pandemic, because they don't want their employees having to go in and, you know, interact with customers who might be, unfortunately, you know, have COVID. And so that's one of the things that I think is going to be interesting to see. How is automation and how do you get people less involved as a result of that? And AI is going to support that kind of process. So,
in general, what I've seen is that there's a broader acceleration of cloud onboarding and data onboarding and people's desire to make do with less. So, you know, I think it's really just an acceleration of the applicability of AI.
Yeah, I agree. I mean, the fact that we're doing this panel virtually is a testament to how technology is being reintroduced into everything that we do, and we're seeing the opportunities, and whether they're enabled by AI or not, the opportunities for technology to really enhance society, enhance how we go to work, how we live, you know, how we play. So I think it's, in terms of the pandemic itself, I think if anything, you know, besides the unfortunate aspects of it, you know, there's a stronger reliance, I think, on data-driven decision making, and I'm seeing more organizations really turn to data science, honestly, as a technique to try to understand and contextualize the vast variety of data that exists in the environment today.
Thank
By
you.
the way, there's an area which may be of interest, and that is that I've seen, it may be COVID related or not, but every physical product now has a CPU in it. And every physical product is talking back to the organization that produced it. And so organizations are increasingly facing a workload, which I guess used to be IT, but now IT is delivering this service, which is understanding what the organization's physical product is doing when it's deployed in customer situations, and that's kind of cool. So every smart car, every tractor, whatever, they're all talking back to the organizations that produce them. And who would have thought that John Deere, a tractor manufacturer, would be an AI user? Oh my God! Yes, they are.
Absolutely. So another question from the audience coming in from GJ. The question is, most AI implementations do not make it to production or do not perform as expected in production. And what is the hope for AI in the future? Is there a chance that we may hit an AI winter again, especially in the post-COVID scenario?
I'd be happy to take a first stab at that.
Yeah,
I mean, that is really the genesis and the reason why we designed and built and have taken to market this product called Modsy to really accelerate that deployment. There's a lot of AI implementations that never, like I said, make it past a certain TR level or technology readiness level into production, and that's for various reasons. But we're trying to make an easy way for organizations to take it from the lab and get it into the hands of the engineers through consistent use of containerizations and specifications and APIs that make it easily callable, and you can send data to it. I think that there's an opportunity for organizations to take this type of approach, whether it's an end-to-end solution or something a little bit more modular, to really start to take advantage of the governance, the model management, the monitoring aspects of the ML ops and the model ops capabilities that I talked about earlier.
Yeah, I will add that there is still a lot that we have not done in the various machine learning fields. I mean, in terms of what is potentially possible, especially with these deep learning architectures and the amount of data that's out there and the more data we generate, there's so many problems that can still be solved. And if you look at companies for computer vision, for example, most corporations don't have a computer vision team, right? They did not have computer vision, deep learning engineers. It's still a talent and a skill that's widely desired. And if we educate more of the workforce to study these things and to enable them to train their own algorithms and understand how this works, there's a lot more we still haven't uncovered. And as computational power grows and people create better and smarter architectures, a lot of really interesting problems will be solved. The last thing I'll say is that, for us at AI.Reverie, we're taking this approach step by step. We think that if you want robotics in the future, you have to solve perception, right? Because if you're trying to get a robot to get a beer from the fridge and it doesn't know what a fridge looks like, good luck, right? So we'll solve that first, right? Well, we need to solve vision, but then once you solve vision, then you can solve things like robotics more easily and have robots that can actually do things in a more interesting way. So there's still so much that I'm excited about that we can still do. So this AI winter thing, I don't know. My bet's on it's going to last a bit longer, and there's a lot more that the workforce can be educated on and really provide back to the research. So,
yeah, I agree with you on the amount that there is to do, the amount of work to do. My observation is that there is so much data out there that needs to be processed, that the use of these techniques is unavoidable. So there won't be a winter because we just have to. There's no way you can afford to save all the data and think about it later, or whatever it happens to be. It's the best way to deal with your data, to go from data into observations or insights or whatever it happens to be. And there is no shortage of data. In fact, there is more than we can deal with.
There's no shortage of data, and there's no shortage of opportunities to learn how to improve this tradecraft. I think we talked about what some of the CSPs are offering in terms of the training that's available to individuals. Between the data, the training the computing resources that are coming online and are available, I think there's a big opportunity, as Dale said, for a citizen to go out and innovate and create something novel.
I'd like to touch upon a bit about what you, I think Josh and Simon mentioned, that there's a lot of data out there. There's so much data. So any thoughts or comments about data diversity? I think how do you factor that in, given the ton of data out there?
I think there's also a question about data quality. I think that the quality of the data is really important. And I think one of the problems you're always running into is bad data. Meaning in computer vision, that occurs by people annotating things incorrectly and saying this is something else, or it can be data that is actually, just totally nonsensical and actually hurts your algorithms. So, I mean, diversity is certainly important, but I also just didn't mean to sidetrack the question, but it's the quality of the data is a big issue, I feel like, and I think there's so many ways of tackling that. So, Josh, Simon, if you have any thoughts on that, but that's always a concern I hear.
In my world, data quality is not an issue because you know where the data is coming from. So, it's a traffic light or a loop in the road or whatever.
Right.
And so, those things are pretty easy to specify. The problem is the volume. Palo Alto is 4 terabytes a day, but Las Vegas is 60 terabytes a day, okay? And that's just a few thousand lights. And Houston is, hundreds of terabytes a day. So the problem is really volume and where are we going to run this stuff? So you can't store that volume of data and then process it later. Well, you could, but then you'd be late. If you're trying to predict what a city is going to do for the next 10 minutes or something, you can't store it and then think. So there's enormous interest in the world, well, my area, which is translating these algorithms which assume finite data into algorithms which compute on boundless data. That's fun.
Yeah, I agree. I think, listen, data diversity and variety has been a topic that, was introduced when we started talking about big data solutions, and that volume plays into that too. I think more recently we're seeing governments and industry start to take advantage of the available data sets that Simon was talking about, Dale was talking about, combining them with their own data sets. I think that's another dimension of data diversity that is really opening up the opportunity aperture for organizations. And I think one of the other things that we don't necessarily talk about much is that data is becoming intellectual property as well. And organizations and business leaders are just now, have realized or just now starting to realize that they're sitting on a treasure trove that could be monetized or leveraged for competitive advantage and partnerships too.
Yeah. Do you think that trained models will become IP?
Trained models?
Yeah. I mean, I can imagine that as a really important piece of IP.
So I think, to go back to a question that was asked about the marketplaces that exist, and the fact that, one of the dimensions you need to think about, you may expend your resources to build a very bespoke model, but there's always going to be another model that's doing 80-90% of what you're doing. And to your point earlier, Simon, about them becoming commoditized or even open source, I do think that over time, a model that may be proprietary will eventually go down towards something that's more common and openly available.
Sure, yeah, the math, but not maybe trained models. But I mean, what I see is that the mathematical techniques are broadly useful and broadly available, right? Mm-hmm. But training is it's an art still.
It is.
Yeah,
it's an art.
But keep in mind, right? The most expensive part of AI is the data. Like in hands down, the cost of acquiring that data and cleaning that data, and actually the amount of there was a New York Times article about 80% of a data scientist's time is cleaning the data. It's janitorial work, right? So there's enormous amount of labor in actually like getting that data, and the algorithms there's so many out there, right? You go to NeurIPS or conference like that, it's all on GitHub, and not to say that the algorithms aren't important, but when I look at it, it's just so much money is spent on figuring out even the infrastructure of how to collect massive amounts of data, right? That part is a problem that we haven't solved yet. It's not an easy
I
problem. And
agree.
to your point, Josh, around that IP, around the data, right? That makes total sense. Like, you're sitting on a massive gold mine if you have data. This is how Google, Facebook, all these companies, I mean, they are what they are because they have customer data, you know? And
Sure.
it's really quite something. So yeah.
This is a question that I've wondered. Have you heard of the concept of dark data? Data which is excluded. So what about all these data which is excluded and might not have been considered in the models?
In my world, every piece of data is included. So, I don't have the option of excluding things on the fly. I just have to think about it and put it in the model.
You want to go first, Dale?
I look at that as a bias thing. That if you don't include a certain piece of data, the idea is that you don't account for it, right? So there is at least in supervised learning, what are you learning, right? It's input, output, right? So it's whatever you put in, you're trying to learn a mapping to predict something based off of how it's annotated. So that part of it, the dark data, there's things that you might not know is in the data if you have massive data sets, and that's interesting. So there was this whole thing with Microsoft where they created that Twitter bot based off of, and it became this really disgustingly racist, persona, right? And that is a thing that they couldn't control for because they didn't know what they were putting in there. So that's where I think the data can get quite dark, not knowing what you are actually putting in there. But Josh, do you have any thoughts on that?
No, I was gonna end with that bias comment too. I think,
yeah, okay.
When we have volumes of data that we have, you talked about 60 terabytes, Simon, in a day in terms of traffic lights. And as a data scientist, it's unfeasible to think about using 60 terabytes of data to train and split that up. So you're going to take a subset of that data, right? And I think it goes into the controls that we were talking about. How do you make sure that the subset of that data is going to provide the most diversity and comprehensiveness in terms of all the different range of scenarios or outcomes that you can anticipate? And that's where you really need that structure and that governance in place for your data science processes to make sure that you're not excluding data that needs to be part of that training.
And that's hard. Yeah,
that's very hard.
It's very hard.
Indeed. And so it's a second question from Barry Shalley. So his question is, how do you suggest businesses figure out the monetization model? Because internal monetization might be quite different from external. So maybe the first part of the question first, how do you suggest businesses figure out the monetization model? Because it's something definitely on the mind of business leaders.
So just to clarify, is the question about once you build an AI product, how do you make money off of it? Is that sort of what it is, if you want to be profitable with it? Or how do you incorporate that into your overall revenue stream? Or I guess I'm just trying to get an understanding there.
Barry says it's from the data. So how do you figure out monetization model from the data? Because I think someone mentioned earlier that companies are sitting on treasure troves of data, but how do you suggest businesses figure out the monetization model?
Oh, okay.
Well, I'll take a. Go ahead, Simon.
Go for it. Go for it.
No, please.
Okay, I'll tell you another one. It's also a fail. So this traffic data, 4 terabytes a day from Palo Alto or 60 from Vegas. It's publicly owned. It's paid for by taxes. So, and the customer is not the city. The customer is Uber. Uber wants better predictions, right? The city doesn't know what the hell to do with better predictions. They don't know how to sell that to or deliver to their populace, right? So the problem with monetization is, what's the business model? Do you have the right to take publicly owned data and then produce a prediction and then sell that to Uber? And if you do, how much is Uber prepared to pay, say, per intersection per month? I can tell you a number, but you have to ask me.
What's the number, Simon?
It wouldn't buy you a hamburger.
Oh.
So the current going rate for prediction is about 25 US cents per intersection per month.
Got it. Yeah, it's really hard to know how to monetize the data without understanding where and what your data is supposed to do, and in which vertical it's supposed to work in, and all of that. So obviously, if there's also questions about monopolies, right? So if you have a data monopoly and nobody else has that data, there's different ways of monetizing that, which is obviously a lot better and unfair in some ways, in many ways. But so it's you have to ask yourself those questions, right? Where is this data coming from? What it's going to be used? Which market? Like, for example, social media data. Not many companies outside of Facebook and have that data, and so they can monetize it in a way that's really hard for anyone else to.
I'm
Yeah,
conscious of time. Sorry to cut you off there, Josh.
That's okay.
Again, along similar veins, I just want to ask this final wrap-up question. With all that we've discussed today, what do you believe is the way forward for businesses? Just a quick or short answer from maybe all of you.
Sure. So it kind of goes back to what I'm excited about. For me, I started, AI.Reverie with these first principles of what I think I want to see the future as, which is the combination of synthetic and real world data, that when you combine the two and you create tools around it and a platform around it, it's going to accelerate the field. Just like certain types of, like the microscope allowed for open new possibilities in research in biology. So the way I want to think about that and I'm excited about is, how do we create tools that can help further develop new advances in the field that you care about? And for me, that's synthetic data and computer vision.
Thanks,
in my world, it's really about putting the great work of these other chaps to work on data. So building relatively simple models on the fly and letting them learn and predict their future or whatever it happens to be without much human involvement. I think making these tools accessible to humans without them having to get their hands dirty on either training or the mathematics of how you predict is crucial. And so making it broadly available is fundamental. And both these guys are doing that.
Yeah, I think if I were to add to a comment that Simon made earlier, listen, we're all carrying around this backpack of tools, and AI is another one of them. It's a tool that certainly can enable efficiencies and effectiveness in whatever business or mission that you're in. And I would advise business leaders to go both feet in and take a chance with this. You have the data likely in your organization. You're going to have to do some work to clean it up, but you can augment and supplement it with synthetic data. And there are algorithms that exist in the open source or commercially that you can start using today. So there is an opportunity for businesses to start using it today. Eyes wide open, understanding the risks and social and ethical implications is also important.
Great. And with that, thank you very much, panelists, for your time, energy, and insights, and all of you in the audience for participating and engaging in conversation. The panel is over, but the work for efficient and effective deployment of AI isn't over, and over to all of you to help make an impact. Thank you very much and have a pleasant day or evening ahead.
Great. Thanks for moderating.
Thank you.
Thank you.
Thank you.
Great.
Thank you, Josh. Thank you, Dale. Thank you, Simon. Thank you, Annabelle, for this wonderful panel discussion. So we would like to also thank all of you for attending. We hope you have learned a bit more about the impact of AI and the concepts of AI in your business or organization for better ROI. So just keep an eye in your email inbox for our post-event EDM. So it will contain the link to today's recording. And do help us to improve our future events by dropping your feedback into our form after this webinar, or it can be found in our post-event EDM. So do stay connected with us on various social media channels so that you can get the latest event updates and news on deep tech. And with that, have a great week ahead, everyone. Stay safe, stay healthy, and we hope to see you at our next events. Thank you, everyone. Have a great day.
Great.
Thank you
Have a
Thanks.
good night as well, guys.
Thank
Thank
you.
you very
All right.
much.
Take care.
All right. Bye.